Hi, this is Mrs. LaBarbara. This is Regents Physics, Chapter 7, Work, Power, and Energy, Video 1. Today's topic is work. The objectives are note definition and equation for work, understand the conditions under which work is done, and the concepts of positive work, negative work, and zero work. Be able to calculate work done using force and displacement of travel. Definition and mathematics of work. So in physics, work done by a force is defined as a force acting upon an object to cause the object displacement. For example, we have two pictures here. Here's a girl is dragging the box. Move it displacement from position A to position B. So the box had a displacement of D. In this case, work is done because that force caused the displacement. Here, two men are pushing the wall. The wall has no displacement, so work is not done. So for work to be done, you need a force, and not only a force, that force have to cause the displacement of the object. Let's take a look at this example. See if is there work or no work. Example 1, a student applies a force to a wall and becomes exhausted. Is work done by the student? The answer is no, because there is no displacement for the wall. Number 2, a calculator falls off a table and free falls to the ground. Is work done on the calculator? Yes, because the calculator had a displacement. But what caused that displacement? Gravity caused that displacement. So work is done by gravity. Number 3, a waiter carries a tray full of beverages above his head by one arm across the room. Is work done by the waiter on the tray? Well, in this case, you'll probably say, well, the tray did have a displacement, right? The waiter is walking around the room, but is that displacement caused by the upward force of the waiter? Well, the upward force applied by the waiter did not cause that horizontal displacement. So in this case, the waiter did not do work with upward force. Number 4, a rocket accelerates through space. Is the work done on a rocket? Well, did rocket have a displacement? Yes. So there must be a force acting on a rocket cause that displacement. So the work is done on a rocket. But what did the work on a rocket? Actually, that work is done by propelled gas. So the rocket expelled the gas, pushing the gas back, and the gas pushing the rocket forward. That's an action-reaction force. Calculating the amount of work done by force. So in your reference table, you can see work done equals to force times distance. But it's a little more complicated than that. Let's take a look at this picture. So here is a box. Suppose you apply a force to drag that box. That force will do work, but how much work is that? This force has two components. One is parallel to the displacement. Let's call that parallel. The other one is perpendicular to the displacement. Only the force parallel to the displacement. This parallel equals to F times cosine theta because it's adjacent to theta using SOHCAHTOA. That F times cosine theta is doing the work. So only this F times cosine theta or F parallel causes the displacement. So the work done by F should be equal to F parallel times D because the other part didn't cause the displacement. So work equals to actually F parallel to D times D. F parallel to D is F times cosine theta because that's the adjacent part to that triangle, right triangle, times D. I can rearrange this equation becomes F times D times cosine theta. That is the work done by any force F at a direction of angle theta above the displacement. So in this equation, F is the force in newtons. Only F parallel, that's parallel to the displacement, that part caused the displacement of the object. So only F parallel is doing the work. D is the displacement in meters. Theta is the angle between the force F and the displacement D. That is the theta. W is work. Work equals F times D. F is newtons, D is in meters, so the unit for work is Newton times meter. We have another name for Newton times meter, that is a joule. So 1 joule equals to 1 Newton times meter. Newton is force. Force equals MA. So we use this M times A times meters becomes kilograms times meter squared over second squared. So a joule, this is the fundamental units expressed in joule. Work is a scalar quantity. That means if you do 3 joules of work, then you do another 5 joules of work, total work would be 8 joules. So it's not a vector quantity. We don't have to use the Pythagorean theorem to add the 2 quantities. It's a scalar quantity. We can just add it algebraically. Work is independent of time. So you can take a long time or short time. You do the same amount of work. Note, this capital W is for work, lowercase w is for weight. Let's take a look at a positive, negative, or zero work. Even though it's a scalar quantity, it can still be negative number. Let's see a case of positive work. Because work equals FD cosine theta, positive or negative depends on this theta. So when theta is greater than 0, less than 90, in this case, this is your theta. When theta is acute angle, then the force acting on the object has a positive component along the object's displacement. This force will increase the object's speed, so that work is positive. Negative, when theta is greater than 90, less or equals to 180. In this case, cosine theta is less than 0. So when the force acting on the object has a negative component along the object's displacement, this case will decrease object speed. This you can think about as you're walking the dog, you're trying to slow the dog down. So you are decreasing the dog's speed. In this case, you're probably like pulling a cart or pulling the dog forward if the dog doesn't want to walk. So you're increasing the dog's speed. You're decreasing the dog's speed. And sometimes you can have zero work. Zero work is when the force acting on the object is perpendicular to the displacement. This is a case of a waiter holding a tray. When you're holding a tray, your force is upward, but your displacement is horizontal. The two are perpendicular to each other. In this case, that upward force did zero work on the tray because there are probably the friction from your hand and the tray will do the work on the tray, but not this upward force. The angle in work equation. The angle in the equation is the angle between the force and displacement, only between the force and displacement. Let's take a look. So a lot of times you were given an incline situation, so the object is pushed along the incline. So the force and displacement, force is along the incline, displacement is also along the incline. Question is, what is the angle between F and D? Well, in this case, F and D are in the same direction. They are in the same direction. They are parallel. So theta is 0 degrees. So don't get confused. A lot of people put 30. 30 is not the angle between displacement and force. Let's take a look at this example. How much work is done on a vacuum cleaner pulled 3 meters by a force of 50 newtons at an angle 30 degrees above horizontal? In this case, here is the equation for work, FD cosine theta. F is 50, D is 3, theta is 30, because this theta is between force and displacement. So plug everything in, you should have 130 joules. You're doing positive work because the theta is greater than 0, less than 90. Another example, Matt pulls a block along a horizontal surface at constant velocity. The diagram shows the component of force exerted on the block by Matt. Determine how much work is done against the friction. This is a constant velocity, so the net force equals 0 because the acceleration is 0. So the friction force and the and Fx has to cancel. Another one, and we also know Fy is 6 newtons. Displacement is 3 meters. Unknown is what is the work done against the friction? Well, the work done against the friction is done by Fx. So what is the work done by Fx? The work done by Fx is Fx times x. Fx is 8, x is 3, so you have 24 joules. Only the x component, that is parallel to displacement, is doing the work. Work for vertical motion. How much work done is by lifting force, which is lifting a 5 kilogram box from the floor to a height of 1.2 meters above the floor at constant speed. Well, work is F parallel times d. In this case, F parallel is Fy times the vertical displacement. What is Fy? Fy has to be the weight, m times g, which is 49 newtons. So 49 times 1.2, you have 59 joules of work. Let's take a look at another example. A 30.4 Newton force is used to slide a 40 Newton crate a distance 6 meters at constant speed along an incline to a vertical height of 3 meters. Determine the total work done by the 30.4 Newton force in sliding the crate along the incline. So F work equals Fd cosine theta. F is 30.4. That's applied force, not the weight. Okay. What is the work done by this force? The force is 30.4. Displaced the crate 6 meters. What is the angle between the force and displacement? That's 0 degrees. So you'll have 182.4 joules. Another example, a constant horizontal force of 20 newtons is used to push a box at a constant speed of 4 meters per second. How much work is done by friction for 6 seconds? Well, the work done by friction equals to friction force. What is friction force? Friction force has to be the same as horizontal force because the box is moving at constant speed. That means acceleration equals to 0 or the force cancel out. So friction has to be equals to 20 newtons. So friction times d times cosine theta. In this case, theta is 180 because friction is backward. The displacement is forward, so there is 180 degrees between friction and displacement. So the friction did negative 480 joules. Kind of slow the box down. Otherwise, without friction, the box would accelerate because the applied force does positive work and the friction does negative work, so they cancel out. Relationship between workforce and displacement. So a neighbor pushes a lawnmower 4 times as far as you do, but exert only half the force. Which one of you does more work? And by how much? Let's take a look. Work done by you is Fd cosine theta. Work done by your neighbor. The neighbor uses half the force, but it has 4 times displacement and use the same angle. Okay, so this will 1/2 times 4 is 2. So that becomes 2 times F times D times cosine theta. Fd times cosine theta, that's the work done by you. So your neighbor did twice as much work as you did. That's it for today. Thanks for watching. See you next time.